Hi everyone. Tonight we're going to talk a little bit about AI-driven development patterns and how I'm thinking about it. This will be a fairly holistic picture, and I will be drawing diagrams along the way. With Opus 4.6, Kimi 2.5, and the agent swarms, making sure that we have reusable pieces in our AI-driven development process has been more useful than ever. All right, so we'll start with me. So this is fairly simple, right? When I first started, we'll have something called ad hoc prompting, right? So because then this is something where we all start. There's fairly different forms of this, but this is certainly where I started. So right, just kind of giving some examples as well. A good form of ad hoc prompting is just me kind of talking to AI, right? You definitely want to give AI a very good first prompt. Sometimes me rambling into voice to speech, and yeah, AI gives me a bunch of work. And then maybe the more advanced iteration of it, you ramble the same rambling into multiple LLMs, right? And then you kind of have each other compare each other's work and then have it choose to merge it together, finding the best of each part of the rambling output. So that's exciting, right? So we'll call this ad hoc prompting, and we'll give this a red. Then there's a reason we're color coding all this. Cool. And then the next iteration of all this, right, is something called spec-driven development. Right. And then what does this look like? Well, it looks like specs. So you have specs at the project level, right, on why, what, and how, and divided up to when, right? So kind of here you can have like overall design principles, right? So all your million tasks do the exact same thing. And right, and my version of spec-driven development, each task gets their own detailed packet, right? From functional design, functional requirements, right, to technical design. So when an agent is executing on a packet on a task, right, and there's many of them, they are very clear on what to do, right? That's kind of like the principle of spec-driven development, is that you review the specs, you produce the specs, and the specs should give AI consistency and everything else. So that's great, right? So that's the second version of all this, and this is really important, right? This is enough to get enough acceleration in the modern world to completely change the way we work completely. And just another version of spec-driven development as well, right? You can use the same concept to spin up a Oracle VM where you kind of plan out ahead of all the things you would need to do, right, within the Oracle VM. And then, you would have AI run it through. And, if you're like me, sometimes I like configuring VMs. I have AI run through it by me before it kind of does a thing with a VM command. And yeah, so spec-driven development works in configuring VMs as well. Especially when Oracle gives away an ARM CPU for free. I'm definitely taking advantage of that. Okay, and then something along the way that's very important here is we have something called prompt logging. And sometimes I realize that it's really important for me to keep a log, mostly of what I'm doing, and then just have AI summarize the response in action. So I am able to kind of keep track of my own work, and this is going to come in important in a big way in a little bit. So one thing about spec-driven development that I want to highlight is that it builds off of these ad hoc prompting. So instead of me rambling, right, what spec-driven development is really doing, right, is really just doing this, right, is really just kind of building on top of ad hoc prompting. And then thinking about this a little bit more, well, I was like, well, let's build a harness, right? And this is where I did another video on this. So what is a harness, right? So a harness is something that, similar to the spec-driven development, at least my definition of a harness is that you still have, right, the project level, the architecture blueprint, right? The why, the how, the what, and the when. So you have the task breakdown, right, ahead of time. And then, right, you have a bunch of task level specs that's planned out. We're allowing for defects. I did a video on this earlier in January. But here's what it could look like, right? You have 22 stories or tasks, right? Kind of gets executed in sequence, right? So it's kind of like taking this approach where I have to manually sit and run each task, right? That takes about 10-20 minutes. Here, we're just kind of stringing over things that takes, 20 tasks that, takes it in. And there's a lot of learnings here, right? This doesn't work the first time. kind of works the second time. But by the fifth time you run it, it's pretty good. And the trick here of doing harnesses is to really think about the input and the output, right? And so you kind of your inputs are the prompt packet, if you will. That's not just a single prompt if you're gonna do that much work. It's really what I consider a prompt packet, right? It's kind of like the thing you exit design phase in consulting out of, right? You exit out of a packet, right? A large set of documentation. So you kind of input in that like a very verbose set of documentation, and then you tune your harness, right? So those are your two input things, right? Your input and your harness, and then your output is what you get. So instead of fixing the output in my harness building, right, I kind of fix either the input or the harness, or have AI figure out how to make it better the next run. And after enough iterations, right, of running and fixing and running and fixing and analyzing while running, you have a pretty good set of harness. But one thing I'm realizing now is that harness, right, is really just a harness is really just an orchestration layer on top of the spec-driven development, right? So we're going to call this harness, right? It's cool. You can do many dollars of current day work, right, in one set of things, but it's really what it's doing, right? It's really doing this. It's really kind of linking harness down, and then this is it's really basically doing this. Right, so it's really doing harness is kind of like a big loop, right? But there's more intelligence, there's more you evaluate the output, you need to make sure that, right? So there's a lot going on. I don't want to oversimplify, but it's basically kind of like it. And the one thing I really want to point out that there's reusable parts to this. And then my fourth project right now, right, we're building a continuous agent. So what does that mean, right? So you have the harness that does build a bunch of stuff, but then you have a bunch of stuff that does a bunch of stuff all the time. So a good example of a harness is that, right, we have things running, it finds different things to work on, and and it's writing on Notion, right? This is no longer a markdown file I'm looking at. This is a human-friendly interface. If I wake up in the morning, I can see exactly what AI worked on, right, in terms of overnight. So it's kind of like a continuous running harness, and there's self-improving tasks it can do. So it can improve itself. It can build me a class skill. It can run a class skill that you built, right? So there's more logic to it, and I did this wrong, right? I rebuild a continuous running agent referencing these, but not reusing. So what's end up happening here is that I now have this thing called 24-hour agents, right? Continue agents, right? So, but the problem with my architecture and short-sightedness, right? What I should have done is I should have really, understanding the modular pieces of this. But what I should have done is not rebuild everything from scratch and referencing, right? What I should have done is I should have realized the modularity of everything, which, whoever comes after me doing this, right, will hopefully, not fall into the same pit. So here, instead of me kind of rebuilding harness from spec-driven fresh, instead of me doing agents, right, and instead of referencing, just reuse, right? So this is where one of my biggest takeaway from doing all these things is that there's common elements, right, within all this. And it's really important to understand and figure out cleverly, architecturally, how do you reuse, right? From me rambling to specs to harnesses to continuous run agents, they all could be reusing the same thing. Whereas my mistake, right, I rebuilt the bottom piece 4 separate times. And it's just very recently I'm realizing I shouldn't have to be doing that, right? I should be building each of these pieces, right? For example, spec-driven development should be reusable by itself. I can run it, right, if I want to. Or I can run it with a harness, or I can run it with a 24-hour agent with a harness. Thank you for watching, and I hope everyone have a great night.